Ugh, my hair. All right, so what we're going to be looking at today is I'm going to be introducing to you all the basic kinematic equations, okay? So essentially what we're going to be looking at today is kind of the computational model in which we can look at and describe motion. So up through now, we've been really looking at how we can do that graphically. So when I'm referring to graphically, right, is when we're talking about like taking our graph, right, for say position time, okay, and then demonstrating or showing like what that motion looks like relative to a whole bunch of different kinds of motion that we've assessed, right? So whether or not we're going at, not moving at all, or if we're increasing our velocity, decreasing velocity, changing with acceleration, those kinds of things, right? We've been able to do that graphically. So our goal today is to really look at, okay, now that I know how to do that graphically and I can visualize what motion is there, how can I take that visualization that's going on in my head or that graphic that I'm looking at on my test, how can I take that and turn it into something that's computational? So how can I just use numbers to help me describe the motion in which I am experiencing or observing? Okay. So what we're going to be using and talking about today is just kinematics. So that's what we've been doing so far, right? We've been talking about how things move, and essentially kinematics is just the study of motion, right? So kinematics, it just has the physics relationship or the association with like the process of moving and how objects are going from one place to the other. Okay, so we're just studying motion as a whole. Okay, so in order for us to visualize these computationally, I'm going to introduce to you several different equations. Okay, so these equations are just extensions of the equations that we've used so far. So far we've talked about how to find velocity, with velocity being the displacement or position in which you travel over time, right? We've also talked about acceleration being that change in velocity over your period of time in which you're traveling, so that change in time. Okay, so these equations essentially are just putting those together in a couple different ways. And our goal today is just really to use them, figure out how to find variables from those that go into those equations, and then solve, right? Try to find the thing that we're interested in looking for. Okay, so these equations, again, help us model what we're seeing with motion. And we're going to use these equations to kind of see what's happening. So what I'd like to do first is just introduce to you what those equations are. Okay, so I'm going to go ahead and erase. I'm learning how to use this like new fancy pad. Whoop, wrong button. So I'm just going to go ahead and erase this stuff. Maybe. Technology, yo. Boom. Oh, I got some of it. Okay. All right, so again, let's just get rid of that. I'm going to leave my awkward moment here because we all learn and we fail and whatever, close enough. So I'm just going to introduce what those equations are. Okay, so with our kinematic equations, we can find a whole bunch of different things. So I just want to list what those things are. So what are the variables that we're interested in finding here? Okay, so with any of our questions that we're looking at variables. Okay, so the variables that we're looking for are things like we've talked about before, right? We've tried to find distance, right? Or how far an object has traveled, right? Distance or displacement. And we know that those things are going to be measured with the variable x, right? We've used the variable x, right? Or change in x, right? Representing a change in position, right? So like displacement, right? You've also seen me use the letter d or delta d. Okay, you can use whichever one you feel is most appropriate, right? D can mean, again, distance or any kind of measure there, okay? But generally I'll use x for the kinematic equations, right? We've talked about velocity or speed, right? And we know that velocity is represented by the letter v, okay? We've looked at change in velocity, right? Which is where you take your final velocity minus your initial velocity. Right, so we've looked at that change in velocity that we get. We've talked about time, right, which we usually measure in seconds, right? So time represented by t. We learned what acceleration was, so a being acceleration. And acceleration being that change in velocity over time, right, represented by the letter a. Okay, so we've looked at all of those different things. Okay, so we know what those things are and those variables are. So the kinematic equations are just showing the relationships of each of those things, so how we can find certain different aspects of motion. Okay, so our first equation I'm going to introduce to you for kinematics is going to be our equation for finding what we call average velocity. Okay, so this would be like, say if I'm on a car trip, I want to know like what was the average speed that I went like as I'm moving from point A to point B, as I speed up, as I slow down, as I have to turn around, that kind of thing. So average velocity is taking into account all of that stuff. Okay, so to find average velocity, what we're going to do is we take our final velocity minus our initial, or plus our initial velocity. Okay, so we add all of those things together like what we do, we find averages, and we take that and we divide that by 2. Okay, so that's how we find our average velocity. Our next equation that we can use, we use this one if, say, we want to find a particular change in distance or how far an object is moving. So this equation is 1/2 a times t, so acceleration times time squared, okay, is equal to or plus vi times t. Okay, so that's the equation. And we'll talk about kind of what those things mean and how those are related here in a sec. Our next equation that you guys are going to be using is v final. So like say I need to figure out the final velocity of something. So the final velocity will be equal to your acceleration times time plus your initial velocity. Okay, and then our final equation is to figure out another way to find final velocity if, say, you don't know how much time it took for you to get to there. Okay, so if, say, you're missing one of the variables. So to see you find your final velocity, what we do is we take that VF and we square it, and that is going to be equal to your initial velocity, that squared, plus 2 times your acceleration times whatever your change in distance is. Okay, so those are the 4 equations. So are you going to be required to memorize these equations? No, right? The point of looking at these equations isn't to memorize them, but to know what each of the individual components inside of this equation represent. Okay, so I feel like the best way for us to go through this is to actually solve a question together. Okay, so in this I want to point out kind of what are the things that we know, what are the things that we can assume based on the question, right, to help us solve something. Okay, so the question that we're going to be looking at is this one down here. So I'm going to leave those equations up there and we'll kind of figure out which one we're going to be looking at here in a sec. So let me move. Okay. All right, so our sample question here. So Chuck is on a ride at a local amusement park called the Giant Drop. Okay, so in this ride, it releases a car and allows it to fall towards the earth. Okay, and then hopefully catches it, but it doesn't say in the question, right? So if Chuck free falls for 2.60 seconds, what will be his final velocity? And then also it's asking you how far did he travel in this case? Okay. Note that acceleration due to gravity when an object falls is negative 9.81 meters per second per second. So again, meters per second is acceleration. Okay, so let's figure out what we know from this question and what we need to utilize to help us solve it. Okay, so like with any question that we've been looking at, let's go through it and try to figure out what we know based on what the question has told us. So what variables do we know, and then which equation is going to help us get to, say, the thing that we want, or we can manipulate to get to where we want to go. Okay, so let's start with this. So here we've got our ride. So we know that the ride is falling towards the earth. So we know the direction, at least, in which we're falling. Okay, so it tells us that if Chuck falls for 2.60 seconds, what will his final velocity be? So what this is telling us is that we know time. We know the time in which the object is falling, and that time takes us 2.60 seconds. Okay, all right, it's asking us to find the final velocity. Okay, so we don't know what that is. It's also asking us to find our change in distance. Right? We don't know what that is. So how far did it travel? Okay, so we need to know that. So we got to find that value. How far did we travel? And then it tells us know that acceleration is negative 9.81 meters per second, or meters per second squared. So we know acceleration. So acceleration is equal to negative 9.81 meters per second squared. Okay, so what it doesn't tell us in the question is we don't know what our initial velocity is, right? It didn't tell us that, but we might be able to infer it based on what's happening, okay? And so we essentially know 2 things about our question, right? And it's asking us to find 3 different things, okay? So let's think about what do we know from this question, right? We want to know our final velocity, we want to know our change in distance, but really in all of our questions, if we don't know our initial or final velocity, right, we're going to have a bad time, right? It's a lot easier for us to figure that out. Okay, so we do know from this question that if our object is falling 2.60 seconds, right, we can assume that it's starting somewhere, right, and then it's going to drop. So our initial velocity would probably be 0 meters per second, right? That's probably a safe assumption for us to make. Like if our object is dropping or falling, right, if we started at a 0 velocity, we know the acceleration, we know how long it falls, we can calculate how much velocity we've built up in that period of time. Okay, so let's do our first part where we're trying to find our final velocity. Okay, so let's look at our equations that we know. So we've got a couple here that include final velocity. Okay, so that is velocity average, which it's not asking us to find, so we don't need to use that equation. But we do want to find our final velocity. So we've got one that includes final as well as acceleration time and initial velocity. We have this one that has final squared equals to our initial squared times 2 times a times delta x, okay? So would I use our delta x equation? All right, let's look. Right? If I look at my variables that I know, I definitely do not know delta x, right? So I would have to take that equation out of here, right? That's one I couldn't use. But do I know my acceleration? Yep. Do I know my time? Yep. And do I know my initial velocity? Yes. So could I use that equation to solve for it? And the answer would be yes, I probably could. So the equation that I would use in this case would be VF is equal to a times t plus my initial velocity. Okay. So let's go ahead and solve for this. Okay, so I know that my final velocity is what I want to find. Okay, I know from my variables that the variable I've been given was this negative 9.81 meters per second squared. So I know my acceleration is negative 9.81 meters per second squared. Okay, and I know that the time in which it takes me to fall is 2.60 seconds. Okay, all right, so I know that. And then I would add to that my initial velocity, which my initial velocity is 0 meters per second, okay? Because I'm starting at 0 meters per second, okay? All right, so if I continue to go through this and solve for the variables in this equation, right, I would take my values, multiply them together to get my next unit. So let me do that. Okay. So I've got negative 9.81 times 2.6. Okay, so for this, my final velocity is negative 25.506 meters per second, right? Because when I multiply these, my seconds cancel out, so I'm only left with 1 second here. And I add to that my 0 meters per second for my initial velocity. However, my value will not change, so my final velocity is negative 25.506 meters per second. Okay, I know that I only have 3 significant figures based on the questions and what I'm multiplying together, so my final answer with sig fig should be BF is equal to negative 25.5 meters per second. Okay, so that would be the final velocity of the car as it's traveling. It's going negative 25.5 meters per second, and that is actually accelerating towards the ground. So in this case, we say towards the ground is in that negative direction. Okay, all right. So let's try to find then the answer to the next part. So the next part of this question is asking us to find the distance that's traveled. Okay, so for the second part here, I again don't know. I'm just going to draw this line here to figure out, to separate that. So again, this one, I want to figure out what my delta x is. Okay, so I need to figure out delta x. So if I go back to my question, okay, or my equations, I could use either one of these, right? I know delta x is equal to 1/2 at squared, okay, plus VIT. Or I know my v final squared is equal to v initial squared plus 2a delta x. I'm just going to go ahead and use equation 2, right, since it's already formulated to equal what I want to find. So I have a value that's going to be equal to, so x is equal to 1/2 at squared plus vi times t. Okay, all right. So let's start solving for that. So I know my delta x is equal to 1/2. My acceleration is negative 9.81 meters per second squared. And I know my time is 2.60 seconds squared. Okay, so again, that's seconds, and this is in the parentheses, right? So I've got to square this thing first. All right, plus my VIT, so that's 0 meters per second, times my time, which is 2.60 seconds. Okay, so immediately what I can do is I can do this math. So 0 times 2.60 seconds gives me 0 meters, right? Those seconds cancel out and I'm left there. Okay, so let's go and do what's here in the parentheses. So the first thing I need to do is figure out what my time is squared. So I would take 2.60 times 2.60. So I get for that 6.76 seconds squared. Okay, and then I would multiply that by my acceleration, which is negative 9.81. Okay, times, just separate all of these things, times 1/2. Okay, and that will be equal to my delta x. Okay, all right, so let's continue to go through the math here. Go down even more. Okay, so in this, all right, so in this I've got my delta x is equal to that value. So if I take my time times my acceleration, I get 1/2 times 66.32 or 3156. Okay, I'm just leaving all my digits in right now. Okay, all right, my units cancel out because my seconds square cancel out. This is the denominator, this is the numerator, so I'm left with meters. All right, plus 0 meters, so I'm going to get rid of that. So if I take that value and divide it by 2, okay, my change in x, right, and this is negative, by the way, so negative. So take that times 1/2, I would get 33.1578. Okay, but again, looking at my question, I've only got 3 significant figures that I could use. So my value would be 33.2 meters, negative in the negative direction. So my change in distance is in minus 33.2 meters, okay? Right, so it's negative because, again, the direction in which I'm going, if I diagram what's happening, right, I'm sitting on this thing with a little car, and that car is dropping towards the ground. Okay, and so I'm saying that's in the negative direction. So my distance changed, right? I went down 33.2 meters, but again, in the direction of the ground. Okay, so this sample question here, right? There's quite a bit that you need to think about. But if we're talking about just kind of our general, things to think about or do as we're solving these questions, the first thing that you always should do when you're thinking about these questions is identify the variables. Okay, so what are the things that you know? Okay. Then once you've identified the variables, which equation has the things that you need? Okay, so once you have that equation that has the things that you need, then you need to just solve, just using simple algebra, for the missing variable. Okay, all right, so that's kind of the big things that we want to do. All right, I feel a sneeze coming on. There we go. All right, so those are the steps that we want to take. Okay, so what I would recommend you do is, again, practice these questions that you've been given, okay, and see if there's anything that you're getting stuck on, like if you're having issues identifying variables or having issues calculating different parts of the equation. Again, our goal here is to really utilize these models to help us computationally figure out what kinds of motions are going on in different scenarios, right, and see what's going on. Some people might benefit, too, from doing these questions if they go ahead and graph what's happening, right? So doing something as simple as position time graph can really give you a good idea of what kind of motion you're seeing. So again, think about what are the values that I already know. Okay, so some people find it beneficial to do that. All right, so if you've got questions, let me know. I'm happy to help you through these. Thanks.